All right, 8.4, we're still going to work with, well, not necessarily solving any equations today, more simplifying expressions. We're going to use some trig identities to do it. Basically, what trig identities are a bunch of patterns that come up with all of our different trig functions, and there's tons of them. There's like no limits to this identity stuff, where if we look at sine, cosine, tangent, secant, and how they kind of relate to each other, all these wonderful little patterns emerge that can help us simplify these expressions when we are working with expressions that have trig functions. Okay? Now, I can't show you a calculator here, so you'll have to either take my word for it or try it on your own. But when you have a chance, go on a calculator and evaluate the sine of 50 and the cosine of 40. Go evaluate the sine of 25 and the cosine of 60 and the cosine of 65. You'll see something kind of neat, but they're the same. Now the relationship here is both of these angles, both of these pairs of angles, add up to 90. Okay? Now, in fact, if I think about a right triangle with its non-right angles, let's call them theta and phi, and then let's call the sides of this triangle x, y, and r. It's actually not a terribly difficult thing to show that if we have two angles that add up to 90 degrees, one of those angles' sine value is the same as the other's cosines. Okay? Because this is in a right triangle, I know these two angles, again, have to add up to 90. Let's look at the cosine value of theta. That would be adjacent over hypotenuse. Let's look at the sine value of alpha. From alpha, side x is opposite, and r is still the hypotenuse, and there you go. Cosine of theta is going to be the same as sine of alpha. Okay? The sine of 18 degrees would be the same as the cosine of 72. Cosine of 89 would be the same as sine of 1. And that's because sine of any angle is the same as cosine of 90 minus that angle. And any angle's cosine value is the same as the sine value of 90 minus that angle. These are two examples right here of trig identities. This is the kind of thing that we're talking about. These little patterns that emerge, like if two angles are complementary, one of their sine values is the same as the other's cosine value. Stuff like this. Now, I'm not going to verify any of these here just because I don't really have the space and it's not a great time to do that, but and especially this one. And if you're interested, I can show you more. I can go. It's not terribly time consuming to go through and verify and prove these that they're correct. For the lesson in class, we'll go through several of these and prove them because they're not particularly hard to prove. So here's another identity. If you take any angle, its sine value squared plus its cosine value squared always add up to 1. Interesting little relationship. Very similar relationship holds true with tangent and secant that you see right here. Very similar relationship with cotangent and cosecant. Don't forget, these generate other, well, I shouldn't say, these aren't different identities. These are still really the same ones. For example, 1 minus sine squared. If I were to take this first one, sine squared plus cosine squared equals 1. And if I subtract sine squared, that leaves me with the same expression just rearranged. Obviously, it looks a little bit different when I do that, but it's the same equation. So here, 1 minus sine squared, I can see, well, that's cosine squared. Okay? And in a very similar fashion, secant minus 1, that's tangent squared. Cosecant squared minus 1, oh, that's cotangent squared. 1 minus cosine squared is sine squared. If you want, pause right now and see if you can fill in the rest of these and discover them for yourself. Secant minus tangent, secant squared minus tangent squared is 1, and likewise cosecant minus cotangent squared is 1. Again, those that we really have 3 trig identities right here. And again, these are called the Pythagorean relationships or the Pythagorean identities because they use the Pythagorean theorem to prove them. Again, right now I've skipped over that part. But when we look at these in class and prove a few of them, you'll see they use the Pythagorean theorem. It's really 3 identities. These other 6 lines have just been rearranged. Okay? A couple others I want to share with you. For tangent and cotangent. Okay, you may recall on a unit circle that the cotangent, let's start with tangent. Tangent of an angle is y over x. Well, remember that the y coordinate in the unit circle corresponds to an angle sine value. X is its cosine value. So in fact, the tangent value of an angle is its sine ratio divided by its cosine ratio. Cotangent, it's just flipped. Cosine over sine. So here we have a pretty good start with 5 different identities that we can use to simplify expressions. Well, here's what we need. Okay, we're going to simplify these. Both of these expressions can actually be reduced down to sine or cosine, as a matter of fact. Okay, I'm going to start with 2 just because it's an easier one. Now, a tricky part about these is it can be difficult to tell where to start. There's nothing to really do with cosine. We could flip that and write 1 over secant, but I don't think that's going to help us simplify it all. We just went over a trig identity for tangent that says that tangent is sine over cosine. Okay, so I'm going to take tangent of theta out and replace it with sine over cosine. Well, multiplying and dividing by cosine cancel, and all that's left is sine theta. Okay, which would tell us that tangent times cosine equals sine. All right, this next one right here is a little bit more complicated, but I'm going to start with the same thing, secant of x minus sine of x, and again, I'm going to take tangent, and I'm going to rewrite that as sine over cosine. Okay, now multiplying those 2 terms, I get sine squared of x, it's coming from sine times sine, over cosine of x. Okay? Now the directions give us a hint that we could simplify this all the way down to either sine or cosine. That tells me that it's not going to do me a lot of good to leave secant of x in here. So that can be replaced with 1 over cosine. And this expression on the right, I will just carry down. Okay? And that's just because secant and cosine are reciprocal trig functions. Well, I'm subtracting fractions here, and I already have a common denominator. So I'll just continue and combine those 2 with 1 minus sine squared over cosine of x. The top part of this fraction should remind you of one of our identities because that equals cosine squared. Feel free to pause for a minute and look back at those notes to see that, yeah, that cosine squared is the same thing as 1 minus sine squared. And finally, cosine squared divided by cosine is just cosine of x. And we see that that whole thing, secant of x minus sine of x times tangent, that is the same thing as just cosine of x. All right, let's try a couple others. I think we'll do 3 and 4, and then 5 and 6 we'll leave for day 2. I don't know if I mentioned that at the beginning. That this is day 1 of 2, so no rush here. We'll do the simpler ones, and we'll leave the more complicated ones, 5 and 6, for day 2 after we practice a few of these. Right here, number 3, kind of looks like a factored quadratic, and it's a case to FOIL. 1 times 1 is 1. 1 times sine x is sine x. Negative sine of x times 1 is minus sine of x. And those last two terms, negative sine of x times sine of x, is negative sine squared. Middle terms cancel. And I am left with 1 minus sine squared of x. Take a look back at your notes. Does that remind us of any of those trig identities? It certainly does. 1 minus sine squared is equal to cosine squared, and that would be fully simplified. All right, number 4 is actually a really short one because we've actually already verified this. This is what we looked at the beginning. Cosine of pi over 2 minus x. This is about those two angles being complements, but instead of looking at them in degrees, we're looking at them in radians. And from that first set of identities I wrote down, if I just substitute 90 in pi over 2, I know that this equals sine of x. Okay? For the same reasons that it was true when it was 90 degrees. Okay? We'll call it quits there. If you want to take a look at 5 and 6, go ahead. I would start with 5. 6 is actually a little bit tougher one. But I'll give you a hint on 5. Start in the denominator. 1 minus cosine squared. We have a trig identity, and when you substitute that one in, this one starts to simplify fairly easy. I highly recommend giving that one a shot right now, and in fact, in 8.4 day 2, we'll do that first thing. We'll start with number 5, and you can verify if you were on the money or not. All right. Again, another day of trig identities coming. Be patient with yourself. They can take a little bit of getting used to because they can be a little tricky. All right.